touch on this topic continuously. Actually, today we're going to probably talk about some of that again. So all these stages we're going into right now, requirement analysis, also called high-level design, design which is typically low-level design, implementation, testing, they're all cohesive and together. So right now, it's not something you can just separate into stages and hopefully it will just fly. It's more like an iterative process. Okay. So we'll go back to some of the concepts we introduced last time, including how to identify use cases, how to represent use cases. Just keep in mind, use cases is one way for you to list the features you want your system to have. Okay, they're definitely not the only way you can list features, right? All right. Any questions regarding requirement, your project, and homework assignment? Yeah, just shoot me an email if you do have a question, or stop by my office. All right. So object-oriented analysis. So essentially, some people prefer to call this high-level design. Okay, just so essentially, when you go to industry and you really start to work, so actually you will feel that many people are actually talking about high-level design instead of talking about analysis. But it's basically the same thing. All right, we're just going to look at a workflow. The key thing here is that this is the first time we are looking inside the system we are building. Okay? So before, when we look at a requirement, that's the first stage. I mean, to deal with any kind of system implementation, you would have to deal with that. Okay? So for that, essentially, you are looking at the system from outside. Remember we draw the box, draw the use case diagram. We didn't look into the system. We basically look at the system from outside. Right? So this is the same thing. For instance, if you go to a car dealership and say I'm going to pick up a car, right? Certainly the salesman at the dealership or yourself probably not into under the hood of car how exactly it's built. More likely you're going to look at what kind of features this car would offer. Okay, the same thing with requirement. So for requirement stage, we're looking the system from outside. For instance, if I'm tasked to implement this box, okay, make no mistake, this box itself is a small computer. Very cheap. Probably the computer itself. I mean, I think they did charge PSU quite a bit of money to the whole thing, but the whole thing, the computer inside probably $1. Okay, circuit board together probably less than $10, $5 maybe. Okay. So if I'm going to look to say, oh, I'm going to implement this box, provide the functionality. Okay? Right now, when I look at this, I'm looking from outside. I'm not looking at, okay, how exactly the circuit is laid out. That's not even something we're going to talk about in our class. You have to go to basically ECE when they talk about how they make the chip and the circuit board and got the wire all together, makes all these buttons work. I mean, these buttons, they don't work magically. Okay? Some poor guy in ECE with background in ECE and other things, mechanical even, actually designed this and made it work. Some manufacturers all over the world, in Asia, in Europe, actually implement the component the way. I mean, I wouldn't be surprised if a component, if we've seen this device, actually come from 15 countries. Okay? So we're not in the business of making hardware. We're in the business of making software to drive those hardware to work, right? So when I look at the system, if there's no software inside, okay, I'm the guy tasked to implement the system, all right? The first step is what's so-called requirement stage, right? In that case, I'm just looking at the system from outside, okay? This thing has buttons I can push. That's basically what I can see. Certainly, this is not that simple because they also have signal converter and those things so that you can plug in your computer and so forth. A little bit more complicated. Put that aside. Just say we already have it hooked up. Then essentially I can switch around and say, okay, I can mute the display. Nope, that's a functionality, right? So that's essentially, I'm looking at a system, play around the system from outside, right? Then I can say, okay, I'm going to switch to laptop. When there's no laptop, because I haven't hooked this laptop in. Or I can go back to my PC, which is basically the computer in the table, right? What I'm doing right now is playing with this device. But if this device doesn't exist, then essentially I'm actually picturing the requirement features I need from this box. That's what we did last time. Okay? Well, our little chat app, we basically enumerated the functionality it should have. Okay? Pretty much you are already halfway done after last class about your first document, right? It's just your job is go back and just flash it out, right? But all the major use cases we already identified. Okay, so we are looking at, so this is the requirement stage. Basically, you actually go talk to your customer and say, what exactly you want from this system. Let's put that down. Let's not talk about how we're going to implement it. How we're going to implement it is with an Intel CPU or NVIDIA GPU or AMD CPU or an embedded system like this one, a Java or JavaScript, C++, and C. That's all irrelevant. Okay? More relevant is what this program is going to do. We talk about we need to, for instance, you have to, if you want to keep track of all your users, you better have a way for people to register. Registered user seem to be a very valid use case. Okay? Now, what if you have returning user? They should be able to log in, right? Great. So that seems to be the first two steps when you take care of. Otherwise, we don't have a running system. At this stage, we're not going to be too worried about whether your app is actually totally secure or not. That's not our business in this class. But you need to be careful. That's actually going to be a major thing. Okay. Then next one is what is the main functionality of that app? Basically, send messages. Right? You can't just say, oh, my use case is to send message. You could actually make that your use case. But that use case would be too big. I mean, you will feel this is too big, too complicated a use case. I need a smaller one. And this comes from your experience, actually. Then we have use case of sending to everybody on the chat platform, sending to one person, and sending to multiple people, right? So whether actually you're going to implement sending to one person and a couple of people at the same time with as the same use case or not, actually that's up to you. You can actually partition them into different things.
Wait, we have to do a case where you send it to 2 or 3 people, but not everyone?
Yeah. You can define a group. Custom, yeah.
I don't remember seeing that in the requirements.
Yeah, remember instance, you have to send the message to all of the people who is online, but not offline. But probably not requirement for just build up a group Yeah,
Right,
sort of.
right. So sort of you
Are
have.
talking about subgroups or just groups?
So yes, so when you have people online, right? That is essentially you have a group, right?
Oh, like
But not
online group.
specified.
No, you're not required to specify the
Oh,
group.
okay.
Certainly, that will be the natural next step. And actually, many of you actually prefer to do that instead of to just have a default group, right? Default group is actually harder to manage in some cases, right? So those.
Just send to the people who are online?
Yeah, people who are online right now, they form a group, right, pretty much. But I can try different test cases when you have different people online, then essentially you have to handle a variable number of people. Okay? So that was our process of trying to enumerate requirements of the system. You have to have that, right? I don't care how you write eventually, when you go out to work, you're on your own, how you are going to write down the requirement items yourself. That's not my business. Okay? This is not something I say, oh, for the rest of your career in computer science and in programming, you have to use cases. No. No. Use case diagram, use case, is just one vehicle for you to specify your requirement. You can buy a bike to commute to work. You can walk to work. You can take the bus. You can drive a car. That's up to you to decide. But you have to need a way to get to work, right? So essentially, you need a way to write down your requirement. Right now, we're just going to use one for our class, and this actually is one that's fairly popular in practice. Okay, but there's no reason to say, oh, I'm just going to write down it in text. Feature 1, feature 2, feature 3, feature 4. There's nothing wrong with that. If that works better for you, if you decided that's going to be your way of listing all your requirements, go for it. Okay, but I think that for communication with other people, so far people feel like a diagram-based approach will give you some benefit. That's why when you guys have the group discussions before, I'm pretty sure you have drawn a lot of diagrams also. Okay? You may actually communicate with your own type of diagram that your group actually understand, but this is a diagram that I would say most software engineers would understand. Okay? All right. Today, our focus is actually dive into the system. Okay? So our goal here is to find out what are the top level components of your system. In a small system like ours, essentially, the granularity of component is more likely to be your Java classes. Okay? Actually, in our case, we intentionally introduced the complexity called socket programming to ask you to separate your program into two, right? Essentially, you have a client side, you have server side, right? You see, that's components by themselves. We basically sort of, in the problem, embedded a level of hierarchy you have to put above your class. Okay, why do we do that? So how human beings deal with complex systems, complex things? How do you deal with a complex task?
Break them down into small
Exactly.
bites.
There's no other choice. Okay. So there's no other choice. If you say you can by one step you can get to Portland Airport, I won't believe you. You still need to walk step by step. You have to basically break down your travel plan into stages when you get to a certain point and then continue on. Okay? So how human beings handle complex systems? The only way is break down. I mean, with a more formal language, it would be divide and conquer. You partition your system into manageable pieces, then deal with each one of them separately. Then put them back together. This is how our teamwork is done. And also that's why you started with building the smallest component of program, which is typically a method or a function, right? When one level classes in programming, you are pretty much programming a function. Start with that. A C function, a C++ function, a Java method, a Python function, what have you, you actually train to start with that. Why? Why do we do that? Why shouldn't we just put you in CS300 first? Why shouldn't we put CS100, make CS300 CS100? Make the first class you take in computer science before you have any programming background. Why wouldn't we do that? Make it CS100, everybody take that class first. What do you think?
Maybe you want to know how the functions are implemented?
You don't even have legs on the table. I gave you the table, but there doesn't even have legs. Okay? There's nothing you can stand on. Okay? So that's why we start with teaching you how to program a function, a couple of functions, a class, like the stack class we worked on last time, right? It is an entity by itself. It has data, it has the methods to operate on this stack. Okay? You are actually building up from ground, from small pieces, ingredients, into something that has a meaningful functionality. Okay? And here, so that is basically, on 200 level, get you comfortable with programming into that kind of thing. On 300 level, you are building systems. To build systems, what we do is, like we studied here, to break a system into pieces you are now comfortable to program at. Okay? If I can break a system into size of stack class, could I give the class to you to program? Do you think? How about you? If I give you a partition system all the way down to stack size level, I give that description to you, ask you to program, would you be able to do it? Just I give you a class to program.
Oh, just a class.
Yeah. How about you? You? Everybody should be no problem because you were programming my stack class with no problem. Hey, our job, actually designers, architects, their job is to break a big system, huge system, into pieces they can give you guys to program on your current level. That's your job. That's also your job to approach a big system and big project. Okay? Right now, you know how to program stack, you know how to program list, you know how to write a tree, you know how to do a simple search on the tree, right? You have all the building blocks. So this is like Legos. You have the building block for Legos. I give you a building block for Legos. And right now you're going to, so basically you're coming with a recipe you can follow to build that system up. Okay? Right now you guys are all comfortable with stack, that level, that size, 50 lines of code. That's probably very reasonable. Okay, give me that job, give me an hour or two, I work on that, I feel very comfortable, right? So how do we leverage your skill set on that level? We follow this kind of design process to break it into 20 jobs, with each one of them of the size of the stack, and require you to program 50 lines of code. Okay? If we design right, we program that, ask you to program that 20 times Then we got 1,000 line of code worth of system which can put back together and work. And certainly in the process, you need to learn how to assemble all these objects already programmed back into bigger and bigger thing. That's part of our job too. Okay? That is basically software engineering discipline all together. That's how software engineering team actually is structured. You have different people on different level. People have more experience and more skill set, and they are architects. They are basically partitioners. Partition work into small pieces. And how you may say, oh, what is the granularity of things that they should partition to? I mean, for our level right now, we are comfortable with 50 line of code worth of like complexity like a stack, like a binary tree. Yeah? If we are all on that level, you as an architect would have to partition the system into module of that granularity. Right? However, if you graduate with PSU, we pretty much think that handle a system of this complexity, the chat app, which is a couple of thousand line of code maybe, you should be okay. So then I may just say, then as an architect, you can just partition to that level and stop. Okay? It really depends on how skillful and how what kind of expertise and capability your team, your teammate, they are comfortable with. Right? If you're comfortable with programming 50 line of code, the task should be 50 line of code. If you're comfortable with programming 1,000 line of code, then I can give you 1,000 line worth of code kind of work for you to finish. Right? Then essentially that's how a software engineering team